Hello Spartans, I hope you had a blast of a new year, and that 2024 is the year you achieve whatever milestones you set for yourself. This year I want to explore more technical aspects of the field, as my background and practical experience are heavily technical, and career coaching is just one of the hats that I wear. It is no surprise that I recommend every cybersecurity professional to learn how to code. Some will say that they don't want to build any tools or automation, and for those today I have a special gift. Stop the video at each of the following scripts and see if you can understand what they do, or at least how would you go about figuring that out. And go! If you understand code, then you probably felt like this.
This is the worst!
And if you don't, you probably felt like this instead. See, programming is a cornerstone in cybersecurity, and not because it allows you to build tools and automate processes, but because it allows you to be a good incident responder and even security operations analyst. Some will wait for the reverse engineer to arrive from lunch to support an investigation, but not the CyberSpartans. But enough motivation, roll the intro. Before I give you a list of languages to learn, it is important to understand how they are classified. Because I want to keep things simple, I will narrow down the classification to relevant categories that fit the most common programming languages for cybersecurity professionals. And those languages are C, C++, Java, C#, Golang, Python, Ruby, Bash, PowerShell, JavaScript, SQL, and markup languages like HTML, XML, and CSS. At a high level, there are two programming language paradigms: imperative or procedural, and declarative. C++, Java, Python, and most programming languages that you hear about are called imperative or procedural, because you write your program by defining a set of steps to reach your final goal. As an example, let's assume that you want to write a Python script that downloads a PDF file, computes its MD5 hash, and compares it with a hard-coded hash that you know beforehand. This would be a useful script to check the integrity of the downloaded file. Now, this entire process would translate into the following code. In step 1, you declare the URL for the file that you want to download, as well as the expected MD5 hash. Next, you perform a GET request to download the file. Once this step is executed, the file is now loaded in memory. Next, you are going to get the content of the file and you are going to pass it to a MD5 hashing function. Finally, you compare the MD5 hash for the downloaded file with the hard-coded MD5 hash that you declared at the beginning of your script. As you can see, when you are dealing with an imperative type of language, you need to specify every step to reach your desired goal. On the other hand, a declarative type of language does not specify the how, only the what. As an example, SQL and markup languages such as HTML, XML, and CSS are declarative because you express what you want, and it is up to the engine interpreting these languages to decide the steps that serve your request. Now, a paradigm classification is concerned with the logic of the program. But how about the representation of data and state? This is where object-oriented programming languages come in. Following up on the PDF downloader example, let's now imagine that you want to create a tool that not only downloads files from the internet, but also keeps an internal list of metadata about these files. And metadata can include name, hash, date and time of the download, as well as the original URL. The problem is now not how to download a PDF and process it, but how to store and represent the information. And this is where object-oriented programming languages shine, as they can encapsulate data, state, and even functions inside a so-called object. Once more, I have an example for you. This time I have decided to dust off my Java skills and create this example of a PDF class for an object. As you can see, the PDF class contains several fields. One of them is the name of the file, the other is the URL, and the third one is the date and time of the download. The class also includes a function which is called a constructor, and the constructor is responsible for setting the initial state of the object when it is created, based on the fields that you provide as input. It is easy to see why object-oriented programmings are such a good choice when you need to represent some sort of entity, such as a PDF, perhaps an animal, perhaps a human, or anything else with a set of attributes. Can you use a language that is not an object-oriented programming language for this task? Well, of course you can, but since that language is not designed for that purpose and does not support this type of abstraction, the implementation will be more cumbersome. Examples of object-oriented programming languages include C++, Java, Python, and C#. Now, we talked about logic and representation of state, but how about syntax and interpretation of data? Let's now talk about typed and untyped languages. Languages like Python are recommended for beginners for many reasons, but likely the most important is the absence of explicit types. See, information used in your program, such as URLs, IPs, or file names, needs to be interpreted, and some languages require you to specify the type of such data, while other languages are able to infer the type based on how you declare the data. Confused? Let's look at an example. In order to explain the difference between typed and untyped languages, I've decided to create two simple examples using Python and my favorite language, Golang. If you look at the left, we have Python. And in Python, as you can see, the only thing that you need to do is declare the name of your variable and the content of the variable. Starting from the top, we have a variable named name with a value Bruno. Then we have age with a value 31. Then we have skills, which is a list. And finally, we have website, which is a URL. Now, even though you don't declare the types of these variables have types internally. For instance, name is a string, website is a string, and skills is a list of strings, while age is what we usually call an integer. And if in Python you don't need to declare types and you don't even see them written in the code, when you look at an example written in Golang, you can clearly see them. If you take a look at the right side of the screen, you see the same codes but in Golang. Starting from the top, we have name, Bruno declared as a string, we have age declared as an integer or int, we have skills declared as an array of strings, and finally we have a website which is a string. Now, it is important to mention that in Golang you don't really need to be explicit about the types. You can simply use a similar syntax to Python. However, what I like about Golang is that you have the flexibility to either declare the types or not, which makes the code much more maintainable while still remaining easy to write. Now, I personally prefer typed languages, which is why Golang is for me the de facto language for performance, ease of development, and maintenance. The problem with untyped languages is that they can be quite messy, because as the code base grows, it becomes quite difficult to tell the purpose of some variables, even based on the names, because you simply have no types. But not everything is bad about untyped languages. Because untyped languages do not require you to define the types for the variables, they are much less verbose, they are easier to write, and they tend to be the best for new programmers, because they don't need to waste their time figuring out what's the right type for a variable. Examples of typed languages include C, Java, C#, and Golang, while Python and Ruby are considered untyped. But at this point, you have decided which language you are going to use, and you have already written your hello world. So what's next? Let's now talk about compiled and interpreted languages. Code by itself does nothing until it's executed. And the process between coding and running is not as simple as most paint it. Compilation is the process of converting your original code into something that is optimized and executable by the underlying physical or virtual machine. If code is executed without previous compilation, then the language, or more precisely the implementation of the language, is said to be interpreted. Of course, most interpreted languages are actually both compiled and interpreted for performance reasons. As an example, most people will say that Python is an interpreted language. But the truth is that the language by itself is neither interpreted nor compiled. But all of the implementations of the language as an example CPython, which tends to be the most common, are a mix of compiled and interpreted, in the sense that your original code is first compiled into bytecode and then interpreted and executed by the Python virtual machine. Scripting languages such as Bash, Python, Ruby, and PowerShell are traditionally considered interpreted, and that is a fine simplification for our purposes. Now, there are other ways to classify languages, such as backend versus frontend, and high-level versus low-level. Regardless, the taxonomy that I have presented to you so far is more than enough for you as a beginner and even as an intermediate programmer. Now, I've just spent a few minutes of your time talking about taxonomy and classification of languages. Why is this even relevant in the first place? First of all, from a developer's perspective, if your objective is to develop a simple script to automate a task, and readability, maintainability, and performance are not top concerns, then scripting languages like Python or even Bash can do the trick with less effort and code verbosity. On the other hand, if you plan on developing a tool that requires high performance and maintainability, a compiled and typed languages such as C#, Java, or Golang is a much better option. If your goal is messing with lower level features of the operating system, such as processes, kernel, and memory, then languages like C and C++ tend to be a better choice, as they are the backbone of all operating systems. Finally, if you enjoy excruciating pain similar to hitting your small toe on the edge of your closet several times in a row, then assembly is right up your alley. Now, assuming that you are not developing any tools and you are just an incident responder or a malware researcher, then you will be looking at source and compiled code of all the languages that I've mentioned before, and even others. But relax, don't be scared. Because if you understand the fundamentals of programming languages, then all you have to do, if you are looking at malicious code of a specific language, is reading up on the specific syntax of that language. And as a matter of fact, if you understand the fundamentals of programming languages very well, you may not even have to look at documentation for a language because you just understand the code by intuition. This happens because at the end of the day, languages are not so different from each other. But you are not a developer or an incident responder. You are instead a red teamer or an exploit developer. In that case, all of the languages above are still worth learning, but the depth to which you choose to go will depend on the stack of software that you deal with and your tasks. As an example, C, C++, and C# are good if you have to develop malware for a red teaming engagement. On the other hand, if you are an exploit developer, C and C++ as well as Python are definitely a good set of programming languages to add to your repertoire. And that is it, Spartans. You are now ready to be a proficient programmer. Until next time, got you now.
Psych!
You have watched this video until the end to find out which languages should you learn. Now, learning can be as simple as knowing how to read a language, but as complex as knowing how to write fluently in that language. The truth is that you don't need to be a fluent coder in all of the languages, or even any language. So I will be defining for you 3 levels, and for each language in a level, I will tell you whether you should learn how to code in it or simply how to read it. Starting with the first level, beginner. In this level, I recommend that you learn how to write using Python, Bash, and SQL. These are core languages that will serve you immensely and are almost a standard for any professional worth their salt. These 3 languages will allow you to write small scripts or even more complex tools, as well as to query databases. Up next, we have intermediate level, and in the intermediate level, I recommend that you learn how to write in Python, Bash, SQL, and Golang. I also recommend that you learn how to read Java or C#. If you understand one, you will understand the other. PowerShell, HTML and XML, JavaScript, and finally, assembly. Assuming you become interested in malware analysis or incident response, languages such as Java or C#, PowerShell, HTML and XML, as well as JavaScript and assembly are a must to be understood. And the reason is simple. A lot of malicious code is still written to this day using one or more of these languages. Now, Golang is a language that I highly recommend if you intend to build tools that have good performance and are maintainable. Now, if you reach the last level, which I call the CyberSpartan level, I expect you to be able to write codes using all of the languages that I mentioned above, including C and C++. Now, before you freak out, I will say that I do not expect you to write fluently and know the ins and outs of the languages that I mentioned above. That is simply not necessary and not the best way to spend your time. What I expect instead is that you are able to write small pieces of code using any of the languages that I mentioned before. I have added the C and C++ to the CyberSpartan level because these languages can be quite useful if you are writing exploits or you need to leverage operating system APIs to access features such as memory, kernel, and processes. Written fluency of XML, HTML, and JavaScript is not necessary, but the obfuscating malicious JavaScript or even HTML may require you to write some code or at least be able to modify it. And that is it, Spartans. Today we discussed the taxonomy of programming languages, and I provided some guidelines on choosing a programming language based on the task at hand. Now you know which language or languages you should focus on. I recommend taking things slow and starting from the beginner level, mastering just a few languages before advancing to higher levels. The reason is simple. You want to build consistency while seeing results. Stretching yourself too thin might lead you to give up once you feel overwhelmed. Quality over quantity, never forget. Until next time, stay safe, stay paranoid.